and then I'm going to hit it again. That way, I can just upload 2 separate videos. Perfect. All right, you know me. I like to ask questions. I like to go to the grocery store because I like food. So, I see you at the grocery store, and I asked you, what's the difference between an equation and an inequality? What would you say? What is the difference between an equation and an inequality? Crickets. All right, we'll try this. We'll try this one more time. What is the difference between an equation and an inequality? Now, before you answer, I really want you to think about it, okay? So to help you think, it's only right of me to do this. I hope you can hear it. Oh, look at the first comment. I use this in my class while waiting for an answer for my students. All right. So you had your opportunity. The difference between an inequality and an equation is that an equation has one and only one solution. An inequality has many solutions provided they satisfy a condition. Now, I'm going to be honest with you. I do not expect somebody to give me those 2 answers right off the top of their heads. That's that neatly at a grocery store. What I would expect is, well, professor, an equation is like x equals 3. Notice in that example, Mr. Float, there's only one answer, and it has to be 3. Otherwise, there's no answer. But an inequality would be something like x is greater than 3. And in this situation, as long as you have a number that's bigger than 3 that satisfies that statement, it would be a solution. So in the second part, in the inequality, 4 is a solution, 5 is a solution, 5.1 is a solution, 3.01 is a solution, 1 billion is a solution, as long as it satisfies that condition. Now, to show that visually, remember, we would do this number line, draw a parenthesis and shade to the right. And then we would write this thing called interval notation because it was kind of a little bit neater. Do you remember doing this? So now we're going to graph linear inequalities. However, I'll just write it here. Now we're going to graph linear inequalities in 2 variables. Okay, so far so good, everyone? All right, now, here's the beautiful part about this. You already know how to do this. You really, really do. We're going to have to solve for y, and then we're going to have to shade, just like we did previously. So let me show you what I mean here, okay? So here's an example here where we're just going to graph y is greater than x plus 1. So to do this, notice it's in slope-intercept form. M equals 1 over 1. My y-intercept is 0, 1. And remember, when you go to graph, you plot the y-intercept first. Okay? Then you're standing at that point. You use your slope to determine the next point. So since it's positive, I go up 1 and then to the right 1. And I put a dot. Here's the thing though. Recall that when we were studying inequalities and one variable like x is greater than 3 or x is greater than or equal to 3, we used different symbols for them. When we graphed, for the greater than, you would use parentheses. For the brackets, for the greater than or equal to, we use brackets, correct? We have to do the same thing here. But now, since we're talking about two variables, our notation kind of switches up a little bit. So here, off to the right, if it's less than or greater than, we use a dashed line. So what I'm going to do here is just draw a line, but I'm going to make it with dash marks instead. Okay, so far so good, everyone? Now I need the shade. Now sometimes it's really easy, all right? But I'm old school, and I like to just show you the proper way that works for every single problem. We're going to need what I like to call a test point for shading. Now, there is always one point I always pick no matter what, unless it meets this one condition, which I will show you in a little bit, okay? But for now, always choose this point. Why do you think I always choose that point? Why do you think I always choose that point? Excellent, Sydney. You read my mind. I choose 0, 0 because multiplying by 0 is easy and adding 0 is easy. And I don't like to think. I like to keep it as simple as possible. So my test point is 0, 0. So what I'm going to do here is this. Watch. Just watch the screen. I'm going to take my original equation. I'm going to substitute in my x and y values respectively. And then I ask myself, is 0 greater than 1? If the answer is yes, I shade wherever that point is. If the answer is no, I shade the opposite side. So, is 0 bigger than 1? Absolutely not. Therefore, I will not shade where the test point is. I will shade above the line. And that's it. That's as hard as it gets. This is all about, do you know how to plot points? Do you know how to graph? And then we got to shade. Are there any questions with that? All right, let's do another one then. All right, so I'm going to scroll up here a little bit. So we're going to graph 2x plus 3y equals... Oh, sorry. Let's make it less than or equal to 6. I put equals 6. I wasn't thinking. I'm going to use the excuse it's Friday and I'm a teenager, so I'm stupid. Did you know that, Amy? I'm only like 19. Amy, how old do you think I am? Be honest. If you're right, I'll tell you.
34.
Not a bad guess. I'm actually 24. I'm lying again. I'll never tell my age unless you guess it. But I am not 34. I wish I was 34.
I can guess.
Go ahead, Sydney. You'll be the last one to guess.
So you're not 34 and you're not younger. So you'd be a little bit up there. So I'm gonna guess 42 or 43.
Nope.
Dang.
Not bad. Not a bad guess, though.
40?
We are no longer guessing, Craig. But no, the answer to your guess is no. We are doing graphing linear inequalities. Now, you know, you got the tools. Somebody, tell me how you would graph this. I mean, I know what I would do. I see this and I go, oh, look at that. Isn't that nice? Why am I so excited? Austin, you're going to help me out with this one. You ready?
Yep.
What form is that line in?
That's standard form.
It's standard form. And whenever something's in standard form, what's the easiest way to graph it?
You gotta turn it to slope intercept.
No, I don't have to. I could if I wanted to. You are not wrong by wanting to do that. But there's an easier way. Oh, what did I just do? Does everybody remember this chart? Remember this little strategy for the most convenient way? It doesn't say this is the way you should always do it. It says convenient. Right here it says standard form. What's the easiest way? Find the intercepts. Now, look at our problem. Is 2 a multiple of 6? Yes or no? Is 3 a multiple of 6? Yes or no? So are you going to have any fractions? Boy, that's great, isn't it? So x-intercept, y-intercept. At an x-intercept, y is always equal to 0. So we get 2x equals 6, x equals 3. So my x-intercept is 3, 0. At a y-intercept, x is always equal to 0. So you get 3y equals 6. Divide both sides by 3. Y equals 2. So your y-intercept is 0, 2. Remember, there are many ways to do these problems. That chart is just a convenience for you. All right, Austin, if you wanted to convert this into y equal, or y is less than or equal to mx plus b, I say go for it. You're not wrong. You're not wrong at all. Austin, where do you live? Like area? You don't have to give me your address, but just an area.
West Mifflin.
You live in West Mifflin. I live in Monroeville. If the goal is to get down to the Penguin game at the start of the game, dropping of the puck, do I care how you got there?
Not really.
No, just as long as you're there in time. Because as much as I like hanging out with you, I like watching the puck drop more. In other words, I just want to be there for the start of the game. That's all. So, I will not change the way you do math. The only thing I will do is assess it just to make sure you were doing it correctly. So here we go. We have the points 3, 0 and 0, 2. There's 3, 0. Here's 0, 2. Now with this question, I have less than or equal to. So whenever you see less than or equal to, or greater than or equal to, that's where we use our solid line again. Okay? Now we got to figure out shading. I choose my test point, which is right there. 0, comma 0. Remember, I always choose that. The next example, I'm going to show you where that fails. So 0, comma 0 is my test point. And when I substitute that into my equation, I get 0 plus 0. And now I ask myself, Dylan, is 0 less than or equal to 6?
It is less than 6.
All right, so I put a yes and I shade that side of the line because that is where the point is located. Does that make sense, everyone? So I think the only like two things that I'm really teaching you here would be the solid versus dashed line and then shading. That's like the two new things in this section. All right. Now, last question of the day, I promise. Let's go ahead. Let's look at a situation where my 0, comma 0 test point fails. Y is greater than or equal to 3x. Okay? This is in slope-intercept form. So my y-intercept is 0, comma 0. My slope is 3 over 1. So when I go to graph this, I put a dot on 0, comma 0 because that's my y-intercept. And then my slope is up 3 to the right 1. So up 3 and then to the right 1. So I'm going to put it right here. I use a solid line because it's greater than or equal to. Now I got to worry about shading. And this is where my test point fails. And the reason why it fails, well, let me ask you, why does my test point fail here?
It's one of the points on the line.
Exactly. It's one of the points on the line. So then what you got to do is you got to pick another point. That's it. Megan H, pick me another point. Oh, maybe you didn't hear me. Megan H, can you pick me another point?
2, comma 2.
2, comma 2, I like that. So let's label it. There's 1, 2, and this is 1, 2, 3. So here's 2, comma 2 right there. That's a great point. Thank you. So that's going to be my test point. So let's substitute 2 is greater than 3 times 2. And that simplifies down into this. So last time I checked, 2 is not greater than or equal to 6. So I will not shade on that side of the line because that's the wrong side. I will shade on the opposite side. So it's up here again. Okay, are there any questions to this? Perfect. All right. So here's what's going to happen on Monday. On Monday, we're going to go over two things. The first thing is we're going to talk about section 5 or chapter 5, section 1. Now, chapter 5, section 1 is called Solving Systems of Equations by Graphing. So the only thing we're going to be doing in that section is legit graphing two lines on the same XY chart or same XY grid. That's it. So all of our answers are going to look something like this on Monday. Okay? Now to give you like an application, like why do we have to learn this? Well, here is our cost and here is our revenue curves or revenue functions. Now, we know in business, profit, that's why you're in business, equals revenue minus cost. And if you didn't know that, now you know. This goes back to the pizza with pineapple on it. You want to make sure that your revenue is larger than your cost because anything left over is called profit. All right? Well, that point right there, everybody, is called the break-even point. And I think, Dylan, I asked you earlier, if you're sitting at the break-even point, who's eating dinner and who's not eating dinner that night?
Your employees are eating dinner, but you're not.
Exactly. Your employees and their families are eating dinner, but your family is not. All right, so that's why you want to make sure revenue is bigger than cost. And we're going to find that break-even point. Now, to extend this further, all right, what if you took this situation where you're graphing two curves or two lines on the same XY chart? Now what you've created is and this is going to sound pretty interesting, if you were to shade, because these would be inequalities, you have this thing right here that's called a feasible region, which means any point inside of this little weird shape that I just drew, including the outsides, any point is going to give you an idea of how much revenue and how much cost you're going to incur anywhere in here. The question becomes, where is it max? Because at max, you are making profit. Companies do this all the time. People get PhDs in this, and they go work for Fortune 500 companies, and they make $50,000. Well, $50,000 is junk money today. I mean, 50,000 is good, I guess. I'd rather make 5 million or 500,000. So $500,000, I mean, they make that stuff by doing math. All this all over again. So we're going to learn a little bit about this on Monday. And then the second thing we're going to do are some word problems. So I'm going to introduce a couple word problems for us. And they're very simple, Dawn. Very easy. Okay? Maybe we might bring Megan D out of the bullpen. Maybe we're making some pizzas with pineapple and chicken on them again. Megan D, have you tried that yet?
No, I'm too scared.
What? Oh. Okay. Is there anything else I want to tell you? Oh, I do want to tell you one more thing. I am potentially teaching a Math 108 next semester. I don't know if it's going to be on campus or if it's going to be on Zoom again. All right? But I will let you know, because I am starting to get like my schedule finalized. And one of the classes that I have checkmarked is a 108. So if you like the way I teach, then by all means, sign up for my class. I will tell you this. If you wait until like a month after the class is released to sign up, you will be put on a wait list. My classes normally fill up within like the first week. All right?
When will we know if it's like in person or virtual or?
When they release the actual schedule.
Okay.
So right now, Dawn, I have two classes. Actually, they're both MAT090 that I will be teaching on campus Monday and Wednesday next semester. So I know that. It's like one's like 9 to 10 and the other one's like 10:30 to 12 or 12:30 or something like that. So I know that. But then my other two classes are Zoom. So this will be the medium for that. But I would say whenever they release the schedule, then that's when you will know. Okay? Now I told them personally, I think a hybrid of the two would work really well. Or at least try it. We'll try it. Like if the class meets 3 days a week, Monday and Wednesday we're in class, Friday we'll do Zoom. Like
yeah, that would work for me.
Personally, Dawn, did I stop recording?